In the previous section, we created a demo app which connects the PhoneGap app with the server side. We will extend this demo to a mobile chatting application. We will make use of the knowledge we gained in the previous videos, such as the Cordova command line tool, HTML5, JavaScript libraries, and server-side technology. In this video, we will go through the demo. Since the app is based on the demo app in Section 7, you need to watch Section 7 first. The project develops a mini instant messaging app, which sends text or image messages between two registered users. Here is the client architecture, which is a typical layered structure implementing the MVC pattern. We have implemented most of the components in the last section, and we will do the rest in this video. This is the structure of the server side. Due to time constraints, the session manager just uses memory to keep a map between the user and its connection session. Here are the core functionalities for this video. Some of you may have noticed that the app uses WebSocket for real-time communication. We use Socket.io in the application. With the power of this WebSocket-based message exchange engine, we could send images from PhoneGap Camera API or HTML5 canvas to our server. Socket.io is a Node.js component, which wraps an implementation of WebSocket. The component is fully compatible with the majority of mobile devices, so it is safe to use in our app. HTML5 WebSocket is a protocol that allows full duplex communication between a web browser and server-side on a single TCP connection. Unlike web requests, which are single-way, WebSocket allows the server to push messages directly to the client. To install Socket.io, just use npm install in your server folder. Here is the usage of Socket.io. On the server side, we find that it attaches to an HTTP server object. Whilst the client side is initiating the connection, the server will receive a socket object representing the connection session. Then, both the client and server side could use that socket to emit or receive messages. To add Socket.io into our app, we need to make some changes. First, in the cloud, as we are using Express.js, we need to get the HTTP server from the Express.js app. Then, attach Socket.io to the HTTP server. Finally, we need to use the HTTP server to listen to our port instead of the Express app. On the client side, in the index.html file, we need to add a script tag for Socket.io. We create a model for Socket.io. The model will first connect to our server and then subscribe to the data event, which will be triggered if the server sends any data. Then, the app needs to initialize a session once the user has logged in with user identifier by emitting a register event along with the user ID. The init function should be called once the user has successfully logged into the app. For this, we add a line of code to our login controller. On the server side, the Socket.io object subscribes to the connection event, which will be triggered when any connection is made from the client. Then, the socket subscribes to the register event to receive the register event from the client. We also subscribe to the disconnect event, which will be triggered if the connection is lost. Finally, we use a variable to keep the map between user ID and their socket connection. Although the client side could use Socket.io to send data, we use a normal web request to demonstrate how to use two communication methods. When a client posts to send an endpoint, it will post its recipient ID so that we could find the related socket object from the map. The socket will emit a data event to target the client along with the data received. On client, the chat controller will manipulate the chat view so that we could render text or image on the chat page. We skip the video as it is only DOM-related code. Then, we develop the content model, which sends text or image to the recipient. It exports a sendText function and sendImage function. Both of them use the send method, which is based on the web model. It will post the data type, data, and recipient ID into the server's send endpoint that we have defined earlier. The send message will return a response depending on whether the message was sent successfully or not. We change our UI according to the response. When data is received in the socket model, we forward it to the chat controller to display it. Once we have our message exchanging engine based on socket I/O, we can send image or text messages. To send a photo from the gallery or camera, we need to use the PhoneGap API, which retrieves the base64 encoded image. Once the image data is retrieved, we call the chat component to draw the picture and content model to send the image to the server. We use navigator.camera.getPicture to retrieve data from the gallery or camera. Once the image is received, we send it to the server. The same code is used for the camera function, except for the source type. The signature pad sends the user signature or drawings to the recipients. The procedure is almost the same as sending a photo, except that the image is from a signature pad. We use a third-party signature pad library to capture the user drawings and retrieve the image data from it. This library can be found online with the URL below. It wraps the HTML5 canvas object. Once the script is downloaded, we need to add it to index.html. First, we need to initialize the pad when the draw page is displayed. The HTML code of the draw page is as simple as a canvas with a send button, so we skip it here. When the draw page is displayed, it will check if the pad exists and creates an instance if not, or if it does exist, it clears the pad. When the send button is clicked, we retrieve the image data from the signature pad and send it to the server. Sending text is no more complex than sending an image with just a different message type. We skip that code demo here. Now we deploy the app to iOS emulator using the Cordova command line tool. First, run the Cordova platforms to add iOS as a supported platform. Then run Cordova prepare to deploy the www folder to the iOS projects. Open the generated iOS project. Now we open another client in a web browser so that we have two clients to communicate with each other. Log into the app for both the clients. Send a text message directly from the chat page. We can send a photo from the More menu. We can also send a signature. If the recipient is offline, the sender will get an error. In this video, we've extended the demo app with the knowledge we've gained from the previous sections. At this point, you should be able to develop a full PhoneGap application. Check out the actual code if you want the full example. The app still needs a lot of improvement.